Perth Linux Users Group, talking Linux and open source.
Cool. Thank you everyone for having me. I don't know the speech off the top of my head very, very well anymore, so I apologize for totally butchering it, but I want to just very quickly acknowledge the traditional custodians of the land that we're on, the Whadjuk people, acknowledge their elders past, present, and emerging, and their continuing contributions to our culture in this land. Hopefully not too bad a butchering of that welcome to country, but with that, so my name is Benjamin Wings Arntzen. Wings is definitely not my real name, nor my real middle name, but it's what everyone at work calls me, just Wings. I am a solutions architect, infrastructure lead for the outer core engineering team at Protocol Labs, which is the coolest company you've never heard of. Wings at protocol.AI, if you're curious and want to email me about work stuff, especially if you know anyone with lots and lots and lots and lots and lots of data that they're willing to upload to the internet, because we would be very willing to hear from them. I'm on Twitter for now, is what it is. I'm on Matrix, which is much cooler, and I'm also known as that one plug president that we couldn't seem to shake. I think I'm either the longest running plug president or I was tied for longest running plug president. I forget exactly which it is, but it was a long time that I was plug president. So my day job, I work on the largest decentralized storage network in the world, which is Filecoin, primarily by running infrastructure for S.Tech, and I'm just going to quickly move my mouse off screen because that's extremely annoying. This is Sid the Dragon. We love Sid. He's our mascot. So Sid the Dragon traveled with us to Canada and the United States and all around when we went to hackathons in universities. We went to Stanford. We went to, we were going to go to Carnegie Mellon University. We went to University of Toronto and a few other different places around the US, and it was really cool. And so let's get into the talk. So the format of this talk has changed because the talk was basically planned before the lab had a number of accidents. So this is now a very impromptu talk, and we'll get into why. So part one will be the Wings lab at PCHQ, which is the location that we're kind of vague about as to where the lab actually exists now. Part two is the questions and answer section. So we'll hold questions and answers until that section as something that's like really burning, in which case just raise your hand. Or if it's funny, then raise your hand as well. That's, if it's interesting, tell me. Part three, we're going to talk about the EHI initiative, which is the near infrastructure for estuary, which is the product I work on in my day job. It's very largely inspired by the lab. The lab, in fact, has helped prototype a lot of the technology that went into it, and a lot of the like Helm charts and the automation code that was actually used to build EHI, or is being used to build EHI. And then part four will be another question and answer section. But first off, this wasn't meant to be this way. I promise the lab normally works better. The technologies that I'm going to talk about are solid. You can build businesses on them. Just learn from my lessons and don't fuck it up the same way I did, and you'll be okay. I highly recommend Proxmox. I highly recommend Ceph on Proxmox. I really promise. A combination of neglect and misfortune struck my lab dead weeks before this talk. For me, that's bad. For you, that means hopefully a more entertaining presentation, albeit with less live demos. I can't just like magically remote into my lab and show you stuff, which is sad. So first off, let's talk about what a lab is. So a home lab, for those who aren't familiar with the hobby, or the addiction, depending on who you talk to. And as a side note, apparently one of my problems is I can't buy just one of anything, especially hard drives. But a home lab is a place to experiment and play. So you get to experience technology that you might not necessarily try out at work. You might get to try open source file systems. You might get to try like weird things like, I don't know, you might get drunk and try RoseOFS one day because like you think erasure coded storage with Mojet transforms is cool, and you don't notice that it hasn't been worked on for 5 years. It's a place to test out new things. So things that you might not necessarily have had a chance to really explore. A place to keep your skills sharp. So, you know, for example, if you're building clusters at work and so on, if you're doing it right, you're not building them every day, because hopefully you're not blowing them up every day. So in the in-between times when you're wanting to like know how an Nginx backend config works, or you're wanting to know, you know, what happens when you pull a disk from a running array, you want to know stuff like that. It's really, really helpful to have a place where you can experiment, a safe place. So it's a home for all your media. The primary reason I have the lab is so my partner and I can watch movies and listen to music and take care of our media collection, which is sorely missed right now because it's kind of down at the moment. It's lots of fun. Genuinely one of the most thrilling hobbies I've ever had. Sim labbing, I highly recommend it. And most importantly for this talk, somewhere where you won't get sued or fired if things go horribly wrong. Why do I home lab? Well, I like big iron. I like big computers. Working for a supercomputing facility for a few years really didn't help this whole thing. It mostly just made I like distributed storage. I think distributed storage is one of the coolest technologies you can work with. Decentralized storage is now my new baby, because I think that's even cooler. But as far as like what you can do in one location with the resources of one person, distributed storage is really cool because, for example, with MooseFS, you can get started with just a couple of Raspberry Pis with some SD cards or some, you know, external hard drives you strap together. MooseFS loves consumer storage. MooseFS is great with consumer storage. I home lab because it helps get me jobs. I think, honestly, like the last 3 or 4 jobs I've gotten because I've had a home lab. Part of it has been I helped like host some test infrastructure for one of the jobs, like on my lab just on a whim, and they were like, "Oh, that's cool. Do you want a job?" I'm like, "Okay." It helps me have fun and de-stress. Now, this is a problem because when the thing that helps you have fun and de-stress is the same thing that stresses you out because you're working, you gotta be really careful of that. The lab is not often a source of stress for me. It's where I go to sort of, it's like a really, really nice Zen garden that costs $400 a month to run. Yeah, probably 400. Let's be honest. But you know, you gotta balance it, and you gotta keep in mind that you have a hobby that has a lot of crossover with work. You've got to make sure you do things like not just extend your work hours into the lab and work on work stuff in the lab just because you can, right? You want to work on stuff that you wouldn't normally work on at work so that you can learn things and so you can actually get useful things out of the lab that you might actually apply at work later. But the important part is you're not doing it just as part of your job and working for free, because that's how you hate your hobby and never want to home lab again. Nobody cares if I blow it up except me. The people using it have no service level agreement besides my partner. There are no consequences for failure other than being sad. Damn, but only about the home lab. It's a little bit annoying to deal with your partner going, when are we going to get the TV back? And it's down all the time. No, it's normally I actually had like years of uptime for a while before this, but yeah. But you know, these are the reasons. So there's other reasons why I home lab, but this is like the most of it is it's a place to experiment. It's a place to learn how to do things wrong and, you know, take away things from that stop you from doing things too horribly wrong in the real world. So what can you actually run in a home lab? What does a home lab do? Well, a home lab allows you to run anything you can run on a computer. So as long as you have the resources for it, you can run it in a home lab. And you could be surprised by some of the things you can run, especially if you happen to have an enterprise gigabit connection with 1,000 megabit in and out and completely unlimited bandwidth and a 4-hour SLA where if anything goes wrong ever, you can call them 24 hours a day and get them to fix it. That helps, but you can get private IPs, you can get public IPs, you can host services in the home lab that would actually give a fairly good experience. And you don't necessarily need an extremely expensive home lab to do this. If you just want to like sync files between your phone and like your home computer so that you don't have to like deal with Google Photos privacy nightmares or like iCloud, God forbid, you can do that. There's free and open source software, at least free software in some cases, as in free as in beer, that allows you to do that. And you can do that on a relatively modest like desktop computer. You can actually buy them off like OzBargain. There's like $150 desktops you can buy that you could stick a hard drive in and run a small home lab on and just run like one Proxmox host, or not even run Proxmox, just run Linux. So, you know, you'd be surprised what you can run on even a small computer. But anything you can do on a computer, if you have the resources to run on it, you can do it in a home lab. So there's things called Plex and Jellyfin. These are like private nets, basically. So you take your media collection, which you acquire by sourcing high-quality, DRM-free movies and TV shows from completely legal sources. And of course, you know, in the countries where it's legal to do this, buying a bunch of Blu-rays and ripping them yourself, and definitely not downloading anything ever. But once you have these files, you can then put them on your media server, and then from anywhere in the world, you can play them back on a browser, tablet, mobile, you know, laptop, whatever you want to play. You have your own private Netflix. It's very cool. I have at times had 30 terabytes of privately acquired legal DRM-free media, completely awesomely acquired. Filecoin and IPFS. Filecoin, probably not super realistic to include it, because to become a Filecoin storage provider and run on the mainnet network, you need about $120,000 US worth of equipment to really get started. And you need about $400,000 to $500,000 US worth of collateral at current values. So unless you have a lot more money than I have, you probably won't actually be doing Filecoin at home. But nevertheless, you can do experiments with Filecoin, and you can learn more about it and certainly store Filecoin data. A little easier and more accessible is interplanetary file system. If you have like NFTs because you're weird, you can help ensure that your NFTs are durable by running your own IPFS node and pinning your copy of whatever files you want. And then as long as you have your copy, then anyone in the world who's trying to access that NFT will actually still be able to, no matter what else happens in the world. IPFS is very cool technology. So you can use those to change the world and earn money through decentralized storage. You could do the same thing with other decentralized storage networks. If you like pain, you can, I can't get through this without laughing, you can run Arweave. Arweave's cool. Virtualization clusters. So if you want to learn more about VMware, if you want to learn more about Proxmox, if you want to like a career in IT, home labbing is really perfect. You learn a lot from experimenting and running this stuff in the real world. And when someone shows you like a VMware system and you've run VMware ASXi and you've run all the like evaluation licenses and so on, if you want about Windows Active Directory, if you want to learn about Red Hat, one of the fastest ways to getting certified and being able to actually like run this stuff well enough to get a job is just to do it in the lab, because your lab resources are the cheapest thing you're ever going to get. They blow the hell out of the cloud. Containers, Kubernetes, this new hot thing that no one's ever heard of, but is eating the entire world. Of course, everyone's heard of it. But you can run Kubernetes in the lab. You'll have pain because Kubernetes on bare metal is pain. But you can totally do it, and it's actually a very good experience to learn how. You can run Docker if you're still into that. Potentially, you can run all this in virtual machines on top of the aforementioned virtualization clusters. And you can run distributed storage like MooseFS, Ceph, GlusterFS, and clearly something that Wings forgot to actually finish the thought on. So what was this talk supposed to be? Well, this was supposed to be a talk about my awesome home lab and why I love it so much. What is it instead? Well, this is going to be about the carelessness and how having lots of hardware can bite you. And the thought I didn't quite have make it in there was that having lots of hardware won't necessarily save you, because part of doing distributed storage, part of doing resilient systems is that you want to make it so that you can lose as many components as possible without actually going down. But if you don't take the time to really care and feed for that stuff, having more hardware is actually going to hurt you more than help you. It's actually a huge double-edged sword, a blessing and a curse. So this will consist of a series of lessons and anecdotes and stories. Lesson 1, do not run with 4+1 erasure coding if you do not plan to pay attention. Well, that probably didn't make much sense to you. Come on, we'll be honest, you're friends with me. What the fuck is erasure coding? It just mean RAID? I mean, technically RAID's a form of erasure coding. It uses erasure coding, but let's back up a bit. So let's do a quick primer on what MooseFS is, so the Moose file system. So the first special thing about Wings Lab, which was sort of meant to be a big reveal, but of course I've been chatting with you guys to kill some time, so it's less of a big reveal, but we have 1,184 terabytes of disk. There are about, I think, 60 to 70 platters of actual hard drives. I don't know how many there are in the lab because I don't have the stats on me right now. And MooseFS Pro allows me to combine all of those into one big storage system. Technically, the MooseFS portion of it's actually capped to 150 terabytes because that's my license size, but we'll get into that later. MooseFS provides one big reliable data storage system and helps deal with failed disks. The idea is that you have this component called a chunk server that's whole job is to take chunks and store them on disks and keep track of which chunks are on which disks. And then you have the metadata servers, also formerly called the masters, which reasons why they're not called that anymore. They store information about files which consist of which chunks exist where, and track who has what chunks stored, what chunks make up what files. And all those components together makes a surprisingly simple file system. So that's going backwards. 1.184 petabytes. I don't believe you. Fine. Here's some photos. So this is the actual lab. What we have here is, if I can recall correctly, this guy here has 2 disks in it. This guy here has 24 disks in it. This guy here has 15 disks in it. This guy has 5, and then it has 6. And then there's 2 up here, and I think there's another 2 behind it. Yeah. Over here is a NetApp, or a couple of NetApp, 24 bays. They're NetApp DS 4243 and 4246s, so very similar models. Running very clearly on some carpet, which is, of course, the preferred method that NetApp intended when they built and designed the DS 4243, was for it to be deployed on carpet and with cables sort of hanging off it. It's very enterprise. Here's some earlier photos, or actually this is not early, this is actually one of the latest photos, but we have a lot of epic compute there, so 32 core, 6-core AMD Ryzen desktop, ironically running the most disks. 15 disk, 64-core processor. Technically, actually, that one's the 64, and that's another 32. That's another 32. like some AMD Ryzen, or sorry, AMD's, whatever the Celeron equivalent is, I forget. I think they rebadged like their old, it's an Athlon 3000G, I think. This guy here is really interesting. This is a COBOL. It's a COBOL Helios 64. COBOL was a company that made open source network attached storage for a little while. And then they made the Helios 64, which was awesome, but had like some problems with it when it launched. And they did like a crowdfunding campaign. And then COVID happened, and the supply chain went to hell, and other stuff happened, and COBOL no longer exists. It's very sad. These guys up here are NUCs. So technically those are not NUCs, they're Nucalikes, or Nucalikes, which are AMD-based NUCs. So they're not technically NUCs because that's an Intel trademark and naughty naughty. But they are Nucalikes. And what you don't see behind them, possibly not in this photo at all, is there's actually 4 NUCs, now 5 because I have an addiction, that basically provide low power compute for the lab. So the idea is, the dream one day, is that when we're not actually using large workloads and we're not actually intending on running anything large, the little NUCs, they burn anywhere from 20 to 50 watts each, depending on what they're doing at the time. So you can run 5 of them for like under 130 watts of budget most of the time, which means that you can then use them to send an IPMI signal to all your big enterprise servers and tell them to turn the hell off and save a bunch of power. I'll get to that point one day. Just need the time. But as far as things that can be shut down via IPMI, this one, which burns 250 watts, this one, which burns 250 watts, this one, which burns 250 watts, and this one, which burns 350 watts. So there's a little bit of power savings on the table ready to go when I actually get around to it. On the right here is this 24-bay JBOD, I guess you'd call it. It's not really a JBOD because it's actually a server chassis that allows you to put it's a storage chassis is probably the most accurate term. Here's a bunch of disks. Very pretty. I've had quite a few boxes of those show up. My deployment of choice right now is 16 terabyte Exos enterprise drives. I get them really cheaply. If you get me drunk, I'll tell you where. This is what they look like. They are enterprise grade SATA drives on a 3-year warranty. They have fairly good performance. They're also very loud. So I'm glad that the lab no longer is where it is on the right. So this picture from the right is an earlier iteration of the lab. You'll see there's actually a very interesting 19-inch rack technology on the right. Believe it or not, the IKEA LAC table, the LAC rack, is actually a 19-inch rack in disguise. You can even mount equipment to it and have rails and all kinds of stuff on it. It doesn't really provide mounting holes, but depending on if you reinforce the legs, because they since worked out they can make that even cheaper by filling the legs with basically cardboard instead of real wood, you can use them as a rack. I did use my IKEA tables as a rack. We had a miner up there. That's a 3090 just sitting in a desktop case with the side open, just pretending that it's, you know, a terrible card and deserves to be in pain, which it did. And then we have a standard desktop computer down here, which with the NUCs on top, and there's one of the NUCs you didn't see earlier. And this was back in the days when you could mine Ethereum, back in those very, very long, ancient, old days. So I did Ethereum mining in the lab for a little while. It was one of the things it did. There's another picture of the lab as it was. Nice little power strip, which is now finally actually mounted. And then this is when I got the first real iteration of the rack that everything's housed in now. So this is it in my apartment in Perth. I think on the right's in my apartment as well. You can see I had less hardware back then, so everything sort of neatly fit within the rack rather than inside and on top. Here's some pictures of wiring it. So standard TP-Link 16 gig switch very, very enterprise, unmanaged. Everyone knows unmanaged switches are the hotness, because who needs VLANs, right? Screw VLANs. And yeah, so you've got some low power NUCs there, you've got the Helios, you've got, you know, everything there. And then of course, on the right here is really interesting. I had a server that needed to go onto Rails, and I didn't really have enough people around to help me lift the fairly heavy server full of disks into the rack. And if anyone has tried to lift a server, they know, you know that trying to mount a server onto Rails without help is a good way to screw up your back. It turns out that I had a foam roller used for yoga, which is very good for server installation because it was just the perfect height where you could plop the server on top of it and then roll the server into the rack. It was awesome. This is a pile of hard drives. This is 688 terabytes of hard drives. I got it all in one shipment, and I could not help but build myself a literal iron throne. So it's just, I probably stole the idea from Linus Tech Tips, if I'm honest, where he just had like the table full of hard drives, and my picture's less bowler because it's not like a full petabyte or anything. But, you know, that's still like, I don't know, 10 grand of hard drives or something stupid like that. I don't even remember at this point. It was a lot. Keeping the lab quiet in an apartment. So this is just a quick side note. One of the cases that I really, really love, which currently isn't on the market right now, sad face, everyone's cry a little bit. It is a case, I think visible at the bottom, which costs you about $210 to $240. For a 4U case that can fit server equipment, takes a standard power supply, and takes 15 internal hard drives. It's a really nice case. The problem with it is it's loud as hell. So what you do is you put fans into it. But if you want to actually have your equipment not die, but still be quiet, well, certain people in the room will disagree with this, but for me, the only way expensive Noctua fans. And not just expensive Noctua fans, but for the 120 mil fans, these guys, I forget the exact brand, but these NBE looped fans, they are horrendous. They're like $40 a pop, but they are super quiet, like absolutely whisper quiet, and they move tons of air. So each of these cases, you buy for about $220, $230, you put a server in it, and then you spend $250 on fans for it to quiet it down enough to actually tolerate living in an apartment. Less of a problem now that we're at PCHQ, but back in the day, that's what I had to do. So let's go back to 4+1 for a second and why it was such a disaster. But first, we'll talk about why it's cool and you should do it. Erasure coding is cool. So storing a file with standard goals in MosaFast requires you to store multiple copies of the file if you care about it, and you should. With 2 copies, you can survive 1 hard drive failure at a time without losing data. And the nice thing about MosaFast, by the way, compared to something like RAID, is as soon as you lose a disk, it will start replicating all the data that was on that disk to everywhere else. So from the remaining copies, it then actually will bring everything back up to goal for you. And you don't have to like replace the disk before your file system starts getting safe again, which is really, really cool if you're going away for 2 months and you don't want to have to deal with that. Really awesome feature of Moose. That standard feature costs 200% of the storage space. So 200% overhead to store data, the best I can do is 125%. 4+1 erasure coding allows you to survive 1 disk failure at a time while only losing about 25% of your storage space, or yeah, you're actually about a fifth. So you're storing your data 1.25 times in terms of real disk space. 4 data 1 parity. So it's a way of encoding a file such that you can reconstruct any of the data shards, the 4 in this equation, from the parity shards if one of them goes missing. I don't understand the math. Please don't ask me to explain it. I do not understand the science. It's just magical. No, really, this isn't a joke. I'm just not going to explain. Talk. But in a 4+1 scheme, you store your actual data in the 4 shards, and then this 1 shard stores parity data. And the idea is, if you lose this, if this drops to be a 3, then you can basically from the remaining data in the 4 plus the parity shard, you can reconstruct the missing piece. So it allows you to basically work around a lot of limitations that you otherwise wouldn't be able to. So the total cost of storing data with one disk safety is 125%. Now, the sensible thing to do, if you then have that working, is to do 4 plus 2, which I didn't put into the presentation, but 4 plus 2 allows you to lose 2 disks at a time for a cost of 150% of your storage space instead of 125%. So you notice that in some senses, with an asterisk because it's not a one-to-one comparison and erasure coding is more complicated, two-way replication, which has an overhead of 200%, is actually less safe under certain circumstances than EC4 plus 2, where you have the ability to lose 2 disks at a time without losing your data, but actually costs less data to store than standard erasure coding. So what went wrong here? Why is 4 plus 1 bad? Well, 4 plus 1 is bad because while I was away in America, I had a hard disk fail while I was out of the country, and it wasn't replaced very quickly. And also, around the same time, I had another chunk server, which was, if we go back to here for a second, these guys here, these little tiny computers with the hard drives sticking out, they have a warranty of 1 month. They're not meant to last for a year-long, multiple-year deployment. I think I had those for about 2 years. The fans in them eventually die. And of course, they're developer boards. They're not really meant to be run in any kind of real capacity. Very good for the home, but not particularly long-lasting. So I had one of the chunk servers running on one of those boxes was in it, and it didn't overheat. The problem was the fan was making such a loud grinding noise that my remote hands, who lives at PCHQ, it was disrupting his sleep and disrupting his life. So I agreed to let him unplug that machine. And what then happened was that the hard drive that had failed, plus the 2 hard drives that were in that node, technically speaking, that was only a 2-disk failure because, the way data is spread out is amongst hosts, not just among disks. But because I basically took out 2 disks at once, all of my 4 plus coded media no longer had parity and no longer could reconstruct it. And the frustrating part is I still had 80% of my data. It just all had holes in it. So the 20% that had, the 20% of it was holes throughout all of it. I Swiss cheesed myself. My media collection was totally hosed. But here's the interesting thing, is that it's not actually a failure of MooseFS. So MooseFS performed as well as it possibly could have from an academic standpoint as far as not losing my data. It worked up to the physical limits of what had actually happened, where it was 2 disks had gone offline. And by the way, the end of the story is not just then we plugged the hard drives back, the machine back on, and everything was good. No, my friend, at my direction, put those hard drives into my NetApp array, and then later on I accidentally formatted them without realizing that this had happened. So that data's gone. But the interesting thing is, why was I using 4 plus 1? Well, all of the data that I was storing was 4 plus 1. I'd made the intentional choice that if I lost this data, I could get it back. It's all Linux ISOs that are fairly easy to retrieve, just kind of a pain. So it's replaceable data, right? I didn't really care about it that much. All the data I actually cared about was stored with 4 plus 2 erasure coding. Every single bit of that survived. So this is a really cool thing about MooseFX, is you have the flexibility of deciding what data is important to you, which folder you actually get to pick how much data safety you have. So for example, my partner's music collection and all my personal documents are usually stored as just copies equals 4. I don't care that it's going to take 3 terabytes to store all of our media, or all of our critical media that's harder to replace, because I've got 1.184 petabytes at a certain point, you got to stop being as picky. But you can literally go into a folder and say, I want this folder to be 3 copies. I want this folder to be 4+2 erasure coding. I want this folder to be 1 copy because I'm an idiot. It's really cool, very flexible. So, recap of lesson 1. Do not, for the love of God, run with 4+1 erasure coding if you don't plan to pay attention. Had I paid attention, had I noticed that there was a failed disk, I probably wouldn't have allowed that machine to be powered off, which would have prevented the first failure because the cluster would have had time to self-heal and that first disk failure would have been dealt with. And then on a second level, had I been paying attention, I wouldn't have formatted those disks. I would have actually remounted them and it would have saved me. Not paying attention here will screw you. So lesson 2, pay attention. Recurring theme, the pain of not paying attention. If you're going to your data, which you should, pay attention, keep regular backups, understand what data is important and understand what data doesn't, and adjust as appropriate. So, this is a story of failure, but it's also a story of success. All the data that I cared about actually survived. Lesson 3. Here's where we get to the fun part, and the reason why this lab talk is so horrible today is do not run Ceph on consumer SSDs. Ceph is great until it's not. Ceph brings lots of benefits to Proxmox. It gives you quick and easy migration between hosts. It gives you scalable storage. It gives you snapshots. It gives you a lot of other fun stuff. But consumer SSDs, they perform like shit in Ceph. They're actually pretty good in most other workloads. If you're on Postgres directly on a consumer SSD, you'll actually have a pretty good time. I mean, don't do it ever, but you could do it if you wanted to. If you didn't care about your data, they don't have any power loss protection, which we're going to go into why that's important. They can't handle large queue depth. Doing multiple things on the SSD at once, it's going to basically turn to just a puddle of mud. And in some ways, you would think NVMe, it's newer, it's faster, it's cooler, all the cool kids want NVMe. In a Ceph workload, consumer NVMe is actually worse than even consumer SATA SSDs in a lot of ways. And certainly, consumer NVMe is a lot worse than enterprise-grade SATA, which thanks to a certain unnamed cryptocurrency where you could mine for money with hard drives, there's a lot of lightly used enterprise SATA SSDs on eBay. You can take from that what you will, but there's a lot out there, and you can buy them, and they're really, really good for Proxmox. My cluster used to consist mostly of NUCs and NUC-alikes. I didn't really get the epics until fairly recently, as in the last few years. They have slots for an M.2 SSD and a 2.5-inch hard drive, and of course, I naively thought, well, I'll install Proxmox on the 2.5-inch drive because the SATA SSD must be the worst one, and I'll put in an M.2 SSD and I'll put Ceph on that, and that'll be awesome. And real servers with real SSDs are expensive. Well, we had a UPS failure which repeatedly rebooted the NUCs. So, is probably ran for many years and got away with this, where there's a thing called power loss protection built into SSDs that are enterprise grade, where if you suddenly lose power or if the host is just randomly turned off or whatever, there's a little capacitor with just enough charge in it that it basically will take incoming writes that were queued up on the bus and will write them out to the SSD and basically do its best to give you sort of a full integrity of the SSD. It still won't like it. Computers don't like being pulled out of the wall, but power loss protection will help save some forms of corruption. And as far as Ceph, Ceph's Blue Store technology, which is much better than their file store technology was, is extremely good. So if you pull a Blue Store disk while it's running, especially an SSD, you will find problems. And it turns out that having a UPS is a good idea. If I had had a UPS for many years, I wouldn't have been at risk of this. However, my friend got me a UPS, and we didn't get 2 of them, which was a mistake, because I have enough hardware that running 2 of them would actually allow me to have enough capacity to survive in a power outage. And so a UPS that isn't powerful enough to survive a power outage is Not super useful. So we had a UPS failure, or rather the UPS went beep and just kind of dropped power to a bunch of machines all at once. And I lost 3 Ceph OSDs at the same time. Basically every single one of my Ceph disks that was on a consumer-grade NVMe SSD died at the same time. Bye-bye Ceph OSDs, bye-bye the entire Ceph, bye-bye data, bye-bye the whole lab. Now, what's really lucky is I had actually, for various reasons, kept my MooseFS metadata servers on, local disks. So I didn't lose all my MooseFS metadata, and all my MooseFS data is still on all the hard drives and still accessible. So I can, when I actually get around to rebuilding the lab, I'll find that all my data is still there. But as far as all the, virtual machines that I had created and, all my infrastructure and everything else, well, have fun rebuilding that, buddy. You're going to have a good time. Lesson 4. This is probably one of the most painful ones. I didn't lose my whole lab over this. I do, however, now have a permanently gimped EPIC machine with an $1,100 motherboard that's basically dead. Do not leave server cases open. So this was just dumb. I was rearranging the lab and putting everything on Rails. I'm about to move to the US, actually on a 3-year internet contract, so it can't really come with me for the next few years. So one of the things I'm doing right now is getting ready to have the lab run by itself with the aid of the person helping actually physically run it. But I want to be able to do everything remotely. I want to make it really resilient. I want to make it survive switch failures. I want to make it survive router failures. I want to just go enterprise grade as cheaply as you can. And rearranging the lab, putting everything on Rails, which, if you're not familiar, is it's a thing for rack-mounted hardware that allows you to actually slide machines in and out without having to remove everything that's on top of the machine, which is really handy when you need to swap out hard drives and stuff. You don't have to take the entire rack down. So I had a running server with its top lid or case open, sitting next to the rack while I was on top of the rack, using the rack as a workspace. And I was adjusting the length of some rails because you have to adjust them to suit the length of your rack to be able to install them. And I was using a screwdriver to do it. And I slipped. The screwdriver fell out of my hand, bounced off the rack, and landed on the server motherboard metal down. Probably should have learned from history. Screwdrivers can be dangerous. Just remember the Demon Core incident, if anyone's familiar. I want to emphasize this. Screwdrivers are dangerous. Don't screw with them. It turns out, though, my worst fears were that the machine was totally screwed because it is a really nice motherboard. It's a Rome D8 by ASRock. They're very expensive. They've only gotten more expensive since I bought mine. I have 2 of them. Now 1, really. It's a PCIe 4.0, which doesn't sound that impressive anymore, by X16 by 8 slot motherboard. So you can run a full-length card times 8 on this thing. It's got dual NVMe SSDs. It has dual built-in 10 gigabit networking. It can run EPIC Milan processors. So until recently, it was one of the most awesome motherboards you could buy on the market. And I was really worried that I'd actually killed the machine permanently. I was worried that there was 128 gigs of RAM in there that was now going to be dead. I was worried about the 32-core processor that was in there that was a few $100 or a few thousand or something. I think $1,600 now. I was worried all that hardware would be dead. It turned out I got off really lucky. One of the RAM sticks, or rather, one of the RAM channels is dead now. So unfortunately, it means that motherboard is forever doomed to run on 64 gigs of RAM, because I can only run it on 2 memory sticks now. All the other memory configurations require the DIMM slot that's dead, so I can't actually use them anymore. But other than that, the server actually still works. So I'm going to basically find another use for it. It'll probably be a MooseFS chunk server, and it's, I'll find something where the memory speed doesn't matter that much, because memory speed is what's mostly affected by having that RAM missing. And For those not familiar with like epics, they really, really love having all the memory channels filled as far as getting peak performance. So that machine's never really ever going to be what it was ever again. Her name was Ambelina, rest in peace. All my machines have names, at least the physical ones. And that name will probably get reused in some other box, and I'll keep using the name. But yeah, I mean, I'm not saying I'm sentimental. But rest in peace, Ambelina. But remember the Demon Core incident. This was, ironically, something that happened twice. I am not remembering the details very well, but back in like the nuclear program, they like were dealing with some fissile material, and they were like holding it up with a screwdriver, like holding the case open with a screwdriver, and there was a slip, and it like split open and exposed a bunch of people to radiation and probably killed a few people, I think, even. And then they did it again. Anyway, the Demon Core incident, very interesting. Wikipedia it. Lesson 4, especially don't leave server cases open while dealing with screwdrivers. But you've heard enough. Lesson 5, pay attention. No, really. Which brings us to the future. Well, so we've clearly had some problems. I lost a lot of my data. I kept all the data I cared about, which is cool. I have to rebuild most for the lab anyway. What are we doing for the future? Well, I'm getting 2 EPYC 7v13 64-core 3rd gen Milan processors. EPYC Milans are lovely. I'm going to pay about, I think it was $6,000 or so to get the 2 of them. And yeah, I have a really good source. Data center pools. And I'm also getting 512 gigabytes of RAM, and I'm going to turn this into one machine. So it's going to be a dual socket 128 core machine with half a terabyte of RAM. And it's going to probably, other than that, I'm going to find a replacement for Ambelina and probably add another 64 cores because I'm finding more use for having more hardware now. And then these. I picked these up. I'm really happy about these. It's one of my favorite purchases in a while. These are the baby 2.5-inch version of those NetApp DS43 and 4246s that I showed off earlier. This is the DS2246. I might get that model number wrong, but it is a 2.5-inch SAS JBOD, just a bunch of disks, that allows you to attach 24 2.5-inch hard drives to a server. Now I got this for about we'll say like $600. So not too bad to be able to put in like a bunch of 2.5-inch spinning Rust or SSDs if you want to. What's actually cool is I got 4 of them for $600, including shipping from Australia. So I'm really excited about that. That's arriving, and it comes with all the sleds. It comes with all the drive trays, so I'm not going to have to like 3D print awful drive trays. I get the actual real thing. Power supply is included, modules included, and it's all SAS 2. So it's 6 gigabit per second per box. Dual head it, so you get 12 gigabit per second. And I'm getting 4 of them. So the plan is slots 1 through 8 on every single one are getting 3.84 terabyte enterprise SATA SSDs. So about $5,000 of flash later, we will have 92.6 terabytes of flash. Seth go brr. 24 times 3.84 terabytes, Seth go brr. And of course, all these SSDs will have power loss protection. They will have high Q depth. They will have all kinds of things that make running a Ceph cluster actually worth it. So we get to the end of the talk, at least this initial bit. This is a screenshot of MooseFS when it was happy and healthy. We have 170 terabytes of usable space. You can see there's like a couple of files missing. These ones are files that I was intentionally only storing 1 copy of. So that's what you see down here is those 2 missing chunks. These ones is like a weird thing where like there's still like a bug in MooseFS every so often where you'll like, it's like Firefox profiles is particularly good at triggering it, where like it'll store a file and then you'll like write to the file in just a certain way while it's storing it. And it can sometimes lose the chunks, especially with erasure coding. But like I have literally hundreds of thousands of files, millions of files that have never had that issue. And I've intentionally tried to trigger this bug before, and I've only ever been able to find it for files I literally didn't care about, like temp files. Everything else it works fine with. You can actually technically run a database on most if you want to, and it'll still perform just fine. This is what the Proxmox used to look like. So 356 CPU threads. They're not actually cores, they're threads. There was just under a terabyte of RAM, which is going to be a little bit less now that I have a node with only 64 gigs of RAM working. But I'll pull the RAM from that guy and put it into a new system, and so I'll get that back. And then you can see I had about 11 terabytes of flash. And so that's the end of the beginning, which, depending on timing, I think we're going till 8:30, so we have a little bit of time for questions. And then I have some live demos to show off of the S3 hosted infrastructure initiative. So with that, does anyone have any questions?
What aspects of the...
Oh yeah, do you want to repeat that in a second? Sure.
All good. What brands or what aspects of enterprise flash would you for a home lab setting?
Yeah, well, so if you're doing it for like enterprise, right, you're going to want to look for like drive writes per day. You still pretty much want to look for that even for a home lab, because like a high drive writes per day or DWPD count is really good for like judging the quality of flash. Ones with like really low drive writes per day, low endurance, that sort of thing, are probably likely to be like cheaply binned flash or just generally not very good. You probably want to get like a mixed workload one, because there are SSDs you can get that are sort of built for write once, read many. And then there are SSDs that are built for like, you know, a mixed workload. So like Kioxia has different brand SSDs that are like designed for different things. But honestly, like there's a glut in the market right now of enterprise SSDs on eBay. And you kind of get to take your pick of what's available, and depending on what's in your budget. Because you can pick up like a 1.92 terabyte enterprise grade SSD, albeit SATA, for about like 120, 130 US dollars right now. And the 3.84s that I'm getting, I won't share the listing, but $183 US a pop for 3.84 terabyte drives US. So I'll be getting 24 of those. And yeah, so I like Kioxias. It's what I deployed in EHI. It's what like Linus Tech Tips really likes. And I just have found really good performance out of those. But really, like Samsung Enterprise SSDs are pretty good. Well, the enterprise ones. Yeah, I'm not saying, yeah, we already covered the other ones. But really, it comes down to like, is it really actually an enterprise SSD, or is it pretending to be? If it's pretending to be, you probably don't want it. So I'd say, like, essentially, if you can afford to pay for them, go Kioxias. If you're lucky enough to get Kioxias on the secondhand market, which I apparently am getting some Kioxias, then you're really lucky. But other than that, like, read reviews, look for like people that have tried to run Ceph on those SSDs. Because if you're trying to run Ceph on them, that's what you really want to look for, is like people who've had experience actually running Ceph, who will tell you whether they're awful. Because these SSDs, like some of them are perfectly good for other workloads, but just absolutely trash at running at Ceph arrays. Yeah. Sure.
These 1.92 numbers versus around, let's say, 2 or 4 terabytes. So the 1.92s do tend to be enterprise. They tend to be specified in drive writes per day, not in terabytes written over their whole life. Yeah. And they will say something like sustained IOPS, as opposed to some peak number which never changes.
Yeah. Yeah, you yeah, there's a certain like mouth feel, because I love that word. There's a certain mouth feel to the marketing of enterprise SSDs that tells you that they're really actually enterprise. You can kind of learn to smell through the BS if you've like looked at enough listings of those. But as far as like buying them secondhand as well, like you want to make sure the wear out indicators, because all SSDs actually have wear out indicators that tell you how worn the flash is and how much lifetime they have left in them. You don't really want to buy anything with less than about 90% lifetime left on it. Ideally 95% or better is better. But a lot of people like bought a bunch of SSDs and then used them to plot Chia, and then didn't even get that far through the SSD's lifetime, and then chucked the remaining life SSD back on eBay and sold it again. So thanks to that, there's just a glut of lightly used enterprise drives on the market. And also the fact that like, if you're in an actual enterprise, you're probably refreshing all your arrays every few years. Like for example, with the HI, we're going to be doing a hardware refresh at like the 3, 4, and 5 year marks. That will, we'll reuse that hardware, but eventually that hardware will probably like get sold to help recoup the costs of paying for new servers and stuff like that. So if you look around, you can definitely find really good deals. And it's the same way with all like the hardware as far as server CPUs, as far as memory, that sort of thing. You're able to get, there's Epic Milans. I've actually been looking for Epic Milans or wanting Epic Milans pretty much since the 3rd gen Epics came out, which is Milan is the code name for 3rd gen Epic. But I've been waiting for the price to lower enough to actually be worth buying. And even right now, to try and buy them on eBay, Milans are too expensive. But in about a year or two, you'll be able to get 3rd gen Epics on the market just fine, and they are extremely power efficient compared to the 1st and 2nd gen Epics. And they also have hardware optimizations that are going to become more and more important. For example, Filecoin wise, they absolutely run circles around Gen 1 and 2. And yeah, so it's sort of like how there's not really a lot of point to running the very, very most bleeding edge gaming PC and playing the latest and greatest games and throwing thousands and thousands and thousands of dollars at, having the very fastest, best gaming PC you can just to run the latest games. If you consider the fact that you can just wait 2 or 3 years and then play the same games on, that same hardware, many, many thousands of dollars cheaper just a couple of years later. So like, there's even a subreddit for it called like Patient Gamers, where people like talk about hardware that they bought, or games that they bought that are a few years old and therefore a little easier to run. Like some people are playing like Portal for the first time, even still. So with that, I guess, yeah.
I'd say guesses for the missing storage stack. I would suggest parallel NFS.
Missing storage stack?
Yeah, or failing that, LizardFS.
For what?
The missing storage stack.
What's the missing storage stack?
In your list.
Oh, yeah, I was going to write Luster, or I was going to write, I probably was going to write LizardFS, yeah. Parallel NFS, I've never actually really played with that much. I have always hated it. NFS is just something I hate. Irrationally, I will irrational hatred. I have actually run NFS lately to transport Chia plots. Oh yeah, that's one of the other things that is sort of a shameful secret of the lab, is a large portion of that data storage that is currently unused is used to store Chia plots, which doesn't make a lot of money, but helps make enough money to help cover the cost of the power of running the lab. So Chia is, I think, not the thing I want to be focusing on for various reasons. It's not really a coin I believe in or anything like that. But very, very handy way of offsetting the cost of currently unused storage, and especially its power cost. So with that, let's have a look at a Proxmox cluster. So hopefully, if we make this guy less big, I did by accident. sort of hard to see with the projector right in the corner there. Okay. Proxmox VE. They can't see that yet. So give me 1 second and I will set up mirroring. So use as main display. Mirror for built-in display. Okay, so this is Vega, or rather we're going to connect to Vega. What's kind of special here is that we're using this cluster as though we were just locally connected to it. If I actually pop open a terminal and I ping the local IP address, right? But of course, this is running in Texas. So what's actually powering that? If you're familiar with Tailscale, this won't be that impressive. Typing's horrible. Sorry, I'm going to get my password wrong a few times. But we're connected via NetBird, and we actually have a highly available NetBird, which is really cool. So there are 3 NetBird instances running on Proxmox on this cluster, which we call the ground floor cluster. And Ceph is in Healthborn, which I know about. I'll quickly just check that it's actually the thing I know about. Yeah, 4 daemons crashed. It's a thing. This is the first Proxmox cluster I've ever had that's actually been fully licensed, which is nice. Although I think technically Pawsey had a licensed one. But we paid for Proxmox, finally. It's like paying for WinRAR, except probably more rewarding. So if we go to the folder view and go to virtual machines, we have a whole bunch of virtual machines running here. And what this Proxmox cluster consists of is, 768 cores of EPIC processors, or 768 threads rather. So it's 8 nodes, 24 cores each times 2. 512 gigs of RAM for each of the 8 nodes, so 4 terabytes in total. And if you go to this, so total aggregate storage that's usable is 34.15 terabytes, or tebibytes rather. And if you go to the Ceph, we actually have 46.58 tebibytes worth of Ceph, but you get less usable storage because of replication and so on. So this is what Proxmox looks like if people are not necessarily familiar with it. It's not something everyone's sort of dealt with before. I'm going to disconnect from the streams for a second, just in case I need to make sure there's nothing on here that's private, because I think this node has some passwords on it. So I'm just going to quickly make sure there's no IPMI passwords or anything visible. It's fine. Okay, yeah, there's nothing visible anyway. So big blue button and share and share. If it was my home lab, I'd just be like, screw it, hack my IPMI, I don't care. This is the customary thing we have to do, is, of course, break the perfectly working screen. That wasn't smart. Hopefully, come on. Plays, Epson, stop mirroring, 720p, start mirroring. This HDMI cable is awful. There might be someone for whom this is like their favorite HDMI cable, and I've just greatly insulted them. But it's terrible. And actually, the adapter I have is even worse. Oh my god. Technical difficulties. This is awesome. I shouldn't have unplugged it. I should have just trusted you guys. Oh, I will pay for that. Okay, well, since we can use an extended display and it seems to work at lower resolutions, hopefully. Come on, buddy. All right, we'll give it one more try. And if not, we'll just revert to good old talking. Because most of the live demos are sort of over with anyway. Come on. There we go. Yay. So, we're going to do the customary thing, which is, of course, to do the over-the-top speed test. This is our data center in Texas. I'm really curious as to how many gigabit per second we're going to get out. It's technically a 20 gig connection. Yeah, that's not a great result right now. We can do up to 10 per single connection. We have two connections. They're bonded together with LACP, which gives us an effective 20 gigabit per second, but only in aggregate. So you can't really reach like 20 gigabit per second on a single client workload. But if you happen to like run BitTorrent or something, you probably could actually get 20 gigabit per second through it, downloading Ubuntu ISOs. Actually, no, legitimately, that is the only thing I use BitTorrent for on this cluster because I'm a good boy. But yeah, so there's that. And what we're going to do that's kind of neat is if we go back to the server view, this is running on Pioneer right now. If you look at the hardware, there's nothing really about this server other than the local disk that puts it entirely on this machine. Now, a neat trick about Proxmox is that, hey, I want to do this demo, but unfortunately this machine is got one of its like storage devices actually on the machine that it's on. So of course I'm not going to be able to live migrate it. Oh no, wait, what? What? Is that going to be fast enough? Yeah, that'll be fast enough. So because we have dual 25 gig networking between every single host on this cluster, we can do absurd stuff like move 50 gigabyte VM images in less than 50 seconds. And just like that, this machine is actually going to now be entirely on Ceph when it was formerly on the local NVMe on its current host, without actually interrupting it. Like, I can keep using that machine right now. If I go to the console, log back in if it needs logging in, it's still usable. I can still like use the desktop while it's live migrating. And it's just moving its storage between, hosts. And it's usable. You can like open whatever things you want to open. And this is straight Proxmox and Ceph. This is out of the box, something you get for free and open source. Yeah. Yeah. It absolutely shits on vMotion. Especially because vMotion costs like more than your car. Yeah, this is free and open source. In fact, you really only pay Proxmox to get rid of the nag notice that pops up when you're, which by the way, I've heard there's a free software project called PVE Nag Buster that just removes that for you. And of course, since it's GPL, that's perfectly legal to do. There you go, that's a bit of a better performance. 2.538 gigabit per second and 1.3 gigabit per second up. So, not too bad. And of course, now we go back here. This machine is now largely on the right storage. We're going to go get rid of its old disk off the local storage because we don't need it anymore. And we're just going to migrate. You know what? I've changed my mind. Let's migrate everything off this machine. Pioneer. Okay, parallel jobs. Yeah, we have lots of bandwidth. Let's do all of them at once. So that's kicked off 4 migration jobs at once. We can go over here and 2 of them just like that. This one has just migrated. It transferred at 1.8 gigabytes a second, a 16 gigabyte VM image, and just like that, that node is drained. And if I wanted to, which I think I do, I can reboot it. And we're going to find out if I can reboot it. based on whether it's a MOSFS chunk server. So Pioneer is one of the ones with lots of disks. I don't actually want to reboot that particular one, but that's okay. Why don't we take a different machine like Capella and just see what happens? Let's just go reboot it. So Capella doesn't have any machines on it right now, so we can reboot it. And of course, Ceph is going to be real unhappy about this. What you're going to see is Ceph is going to, in a moment, notice that a bunch of OSDs are down. There's going to be momentary interruption. This peering is really bad, but goes away pretty quickly. So if anything was using that particular, was unlucky enough to be storing data on that particular Ceph node at that exact time, I/O would have just blocked for about 2 seconds, and then it would have carried on as if nothing had ever happened. It was just as if you just stumbled and almost tripped over and then, picked yourself back up and being. So Ceph will immediately start reacting to the host that's been taken out. If we go down here, the rebalance won't actually kick off straight away because it's going to wait a little bit to do some calculations and kind of work out whether that node's actually coming back. But you can see that there's still, not a lot of activity happening because this cluster is not very active, but there's still like reads and writes happening, and it's still usable. And if I go to that other machine, you'll see that it's still working. And essentially, this red just means, hey, these aren't as happy as they could be. But the cluster is still in line, everything's still working, and for the most part, it'll still work. So Proxmox is really, really cool tech. Really easy to use, really, really, not simple, but actually by far. Pardon? I found Proxmox to be much, much easier than VMware. If you're used to VMware, then Proxmox will be difficult for you because you're used to all the ways that VMware abuses you. But if you're not, then you'll be fine. So, pardon? Well, so it's going to take a while. One of the problems with these nodes is that they have 512 gigs of RAM, and the training time for having that much RAM on DDR4 is actually horrendous. So they take a long time to reboot, and in particular, 3rd gen Epic Milans, essentially with a 512 gigs of ECC RAM and all the memory training that they have to do, you're looking at between 5 and 10 minutes after rebooting a node before it comes back online. So yeah, it's not great. And I've seen plenty of other boards and stuff like that that have the same problem. Physical nodes don't reboot as fast as like VMs that you're used to. And speaking of that, let's have a look at a workload running on this, which is Metal as a Service. What's kind of interesting is that Metal as a Service itself is not actually currently load balanced. This is just the one machine. But this is a new service that I'm working on for EHI. Anyone who might work for Canonical, cough, 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 might be familiar with MAS. But the interesting thing is that this is backed by a highly available Postgres service. And what we're going to do that's really fun is we're going to go to the actual node that is currently servicing this cluster, and we're going to just reboot it. There's a lot of that right now. So 10.24.0.2/32, if we ping that guy, if we ping mas.s3.tech, we will find that, okay, that's that one, but if we ping, so that's the server itself, but if we ping ebi.s3.tech, this is the load balancer, but it's a virtual IP. And what's cool about virtual IPs is let's just pop open a terminal to prod.htaproxy02.s3.tech. And prod.htaproxy02 is another participant in the cluster. It has its own floating IP address as well. If we do watch PCS status, we can see the state of cluster, and we probably need root to do that. So let's get root. And if we make that a little smaller so that we can actually see it, Failed resource actions. Oh yeah, that's fine. Yeah, that's just because like I've been rebooting boxes and stuff. But what we see is we actually have 3 virtual IPs that are floating around here. And what this allows us to do is we actually have load balancers. So the HA proxies are themselves load balanced, albeit badly by DNS. And so the idea is that they will keep all 3 of these virtual IPs running no matter what happens to the cluster. And for certain services where we want to make sure that the service doesn't mind, doesn't have to deal with its connections potentially being interrupted, we can pin that to just one virtual IP. So we have like a HA proxy CNAME that you can use that just gives you one floating IP that isn't itself balancers. But then for like more tolerant apps that can kind of tolerate a little bit of change, you can actually load balance among all 3 of these. So you can then take full advantage of the hardware. And what we're going to do is this virtual IP 1, which is currently on prod HA proxy, we're going to go kill prod HA proxy. Oh, sorry. Yeah. Not a ton I can do about that. Yeah, Big Blue Button is screwy on this machine for that. I'll try it though. Screen 2. There we go. All right. Well, so we'll have missed the fun part, but I just rebooted prod HA proxy 1, and what's going to happen here is that virtual IP has automatically moved to one of the remaining HA proxies. Now this is now imbalanced because prod HA proxy 2 had, one of them had 2 of the IP addresses, so in theory was getting twice as much traffic. But you'll notice what's really cool is that as soon as prod HA proxy 1 came back, things got rearranged. Now, it's a little annoying now that IP 1 isn't on number 1, and for anyone with OCD, I'm sorry. But we can just like redo this trick. So let's just reboot another time. And so we'll see that it goes away. And basically, before I even tabbed back over, that IP address had moved and was now being served again by that other thing. So what that looks like in practical terms is that even though I've rebooted machines, if I go to Maz and use it, it might have timed me out. But oh, live demos, awesome, love that. Oh, I have config that's specific to that node right now. This is one of the other things about like high availability is the human factor becomes more important than the machine failures, because I now need to actually make those configs match before this. No, okay, it's come back. Point is, without much of any interaction, I didn't do anything to fix it. It went down for a second, we'll give it that. But within 20, 30 seconds, the cluster recovered, and suddenly this database is back. And we can go a little more hardcore than that. We can actually go kick a database node. We'll in fact kick the leader, just for fun. So I don't know who the leader is right now. We're going to find out. Okay, so DB03 is the current leader. And it looks like someone's about to trip on the power cord. In fact, actually, why don't we trip on the power cord? That's going to be even more fun. Speaking of things you shouldn't do. Prod EBI, I have backups, so this is fine. And this isn't in production yet, even though it says production. We're just going to do a hard reset. Oh no, it's gone. And how this is going to react is it's going to notice that that leader is gone in about 3 to 5 seconds. We're going to see an error message because the etcd node that we were talking to is gone, but we have 3 of them. So it's still going to be able to basically realize what's happened after a little while. Come on, normally takes less time. Okay, and quickly database 2 is now taken over as the leader. So in a fairly catastrophic event where someone basically just tripped over the power cord of the running, writing Postgres server, we've actually had another node take over automatically, and the application is probably still running. If we go back to Maz, I bet what you'll find is it did the same thing where it's going to have logged me out. Nope, it's still working. So even though its database server just went away, this application still works. So high availability, when it's implemented really well, is awesome. It will make you really happy. When it's implemented badly, it will make you really sad. But prod EBI-DB02 is now the leader, and EBI-DB03 has actually come back already and is synced up with the cluster and is ready for failover again, which we're actually going to do because there's a legitimate reason to reboot one of these nodes. Does anyone see it yet? Got a star, so that means there's probably patches that it wants us to apply. So we're just going to go back over to that guy. We're going to go over to number 2 because it needs some maintenance. And this is the power of being able to do things intentionally rather than just tripping on the power cord, which is dumb. What we can do is we can do sudo-i because I don't know the path to the Petroni config right off the top of my head. My friend would be so proud. He's always telling me, Wings, you shouldn't use passwordless sudo, and I'm finally listening. We're going to do list. And what we're going to do is rather than doing a forced failover, we're going to do a great. So we pick the primary, which is prod ABI-DB02. We're going to pick we're actually going to pick the server that we just kicked. We're going to pick prod ABI-DB03.s3.tech. And we can actually schedule this for some time in the future. So if we know that like on a Friday we want to like do this maintenance, we could just like schedule it. But we're just going to do it for now. Do you want to do it? Yes. And just like that, the leader has transitioned to node number 3. It's now safe for me to go and just like that, this node is now going to run some maintenance, do what it needs to do, reboot, and then within a short period of time, it will come back, rejoin the cluster as if everything was fine. And, you know, we've run some maintenance, we've tripped on a power cord, we've rebooted a Proxmox node. It's been a good day. And other than like 20 seconds of the most unlucky user on the entire code base happening to stumble upon that particular application at that particular time, no one noticed a thing. And so when you're talking about enterprise-grade storage, enterprise-grade stuff, these are the kinds of things that these technologies enable. And I was talking about the kinds of stuff that shared storage like MoSFS, what it can enable you to do. Our current way that we're using S3 is the old version of S3, S3 v1, is what we call the shuttle architecture. So the shuttles are rented boxes from Equinix Metal with 12 8 terabyte hard drives. Some of them, the oldest ones, are LVM RAID 0 across 12 disks, which is awesome, with no backups, which is awesome. We are in the process of evacuating those right now to this new cluster. And the idea of the shuttles was that there would be a place for you to store your data temporarily until it's uploaded to the Filecoin network, and then, you know, the shuttle goes away. What the shuttles have caused problems with is that if a shuttle happens to crash, which it does under the heavy load that our site is under because of being an in-demand service, then the data that was on that shuttle is now unavailable until that shuttle comes back. You have a massive availability problem. What MoSFS is allowing us to do with actually better performance than the individual shuttles could manage is with our big 1.62 petabyte shared storage on MoSFS, we're actually creating a data lake where instead of shuttles, we have data nodes that do the same thing, that allow you to upload data and make deals with the Filecoin network and basically store your data. But the difference is any of the nodes in the entire cluster can go down and the system will keep running. You know, as long as a small number of nodes go down, not all of them are enough to interrupt it. So we have a highly available triplet of HA proxies. We have a highly available set of Ceph hosts and Proxmox hosts. We have a currently only 2-node MooseFS, but we'll soon have 8 nodes of MooseFS, so we can do erasure coding and other tricks. And the whole thing is built almost entirely on free and open source software. So with the exception of like MooseFS Pro, which is like the closed source version of MooseFS, and gives you things like erasure coding that actually works, unlike certain other file systems. It's all built on open source technology, and what's really cool about EHI is that, not that any of it's going to be entirely groundbreaking, but we're going to be architecting it such that any part of the system can build any other part of the system, and such that we can rebuild the entire thing piece by piece, one at a time, like the ship of Theseus. And the goal is that every 6 to 12 months, every single part of it will be reinstalled and formatted. And we're just going to do that on a cycling basis, all using automation tools, Pixie booting, that sort of thing. And it'll be like a constantly renewing ship. And in doing that, we're also going to be able to make it so that other people who want to bring their infrastructure in-house and are sick of the cloud and want to run on something like Proxmox with all the like tricks that we're going to learn with Proxmox can do so. One of the things I'm working on is like, I'm calling it Cloudy Dreams, because I just think it's a cool name. What it does is it uses Proxmox as like a virtual cloud, where you tell it how many nodes you want, how many virtual machines you want, and it will instruct Proxmox to create that many number of machines with all the specifications you've chosen, and it will network boot them into a highly available Metal as a Service instance that will then install Ubuntu, get everything done, and get everything set up. And it will even also, in the process, inject all of the IPMI details into MAS so that MAS is able to reboot and manage all of those nodes as if it was added by hand. And the nice thing is you can do the same trick to Metal as a Service nodes as well. So you end up with a system that, with the current exception of being able to reinstall Proxmox nodes automatically, will soon be able to basically self-heal and repair every single part of itself entirely using automation. And so we're going to be building like a staging test version of this at the lab at PCHQ as part of the rebuild. Highly available DNS, DHCP, highly available build services, highly available HA proxy, highly available database, highly available file services, pretty much everything you can imagine highly available. And we'll just be constantly tearing it down, rebuilding it, and publishing the results all open source. Because as an open source organization, we actually don't have any reason to keep our infrastructure code completely private. All we really care about is that our private secrets and like certificates and keys and so on are kept private. But every other part of it's going to be open source and available for free. So yeah, that's, I think, everything I had. I think we have a little bit of time. Not really. We have some time left over for questions if anyone wants to stick around and ask them. Otherwise, I thank you very much for spending a lovely hour and a half with me. And thank you very much for your time. And I really appreciate the new faces here. I hope you had a good introduction to Plug, and I hope you stick around. It's a cool group. And yeah, I hope you all learned something. So thank you. Yeah. Sure.
You showed us your current home lab, and you showed us what you're going to set up as your new home lab soon when you get all the gear.
Yep.
But you are moving to the UK soon. So what's going to be your home lab when you move there?
Yeah,
Because
so interestingly enough, I don't need to really have too much of a real home lab actually local. So I'm stretching the definition of home lab a bit by having a home lab on a different continent, and in fact on a different hemisphere. The latency is going to be a bitch, and I know the latency is going to be a bitch because the latency to Texas really sucks. But ultimately, like, most of the stuff that I really will want to do is like kick off Ansible jobs and automation and stuff like that. And like the AWX Ansible automation will be running from the lab to the lab. So a lot of the like latency of dealing with the lab remotely won't actually apply to me as far as being able to use it. And then as far as like video streaming and stuff like that, which is really what the lab is meant for, ultimately is the biggest thing it's meant for, other than like learning and career development. That still works totally fine on the other side of the world. It's just, you know, your videos might take a few seconds longer to buffer than they otherwise would. So I'll be able to continue using the lab while I'm gone, or essentially until I over. So the plan is I have a 3-year contract with Aussie Broadband to provide enterprise-grade Ethernet fiber service to an undisclosed location known as PCHQ. And it's a residential place, so it's not really a business, but it is an enterprise-grade service as far as the internet goes. But there's a 3-year contract. It's very expensive. My work is actually sponsoring that as part of my research and development activities because I use the lab for legitimate research purposes. I actually do. Especially for IPFS. Like, I've run IPFS nodes. I run experiments where I push, you know, many terabytes of files around the internet, and it's an extremely handy thing when you need to do something really dumb like install Proxmox remotely over a WireGuard connection, over IPMI, over virtual DVD sharing to Texas from Australia. Having a gigabit connection there, really nice. Especially when that's the only way you can actually lay down an operating system and get a foothold in Texas. Could have also just like paid a remote hand to just put Proxmox on a thumb drive and plug it into the machine, but you know, that would be less fun. We did eventually do that for one of the machines, but we did actually legitimately install Proxmox over the internet from another continent over a WireGuard tunnel with no actual running servers prior to. It was very cool. So the plan is about 3 years from now, I'm going to reevaluate whether or not I want to have a lab running in Australia. We might actually end up, if the productionizing of this lab goes well enough, we might actually run it as a point of presence for estuary and have essentially some shuttle storage running on this hardware because there's enough storage there to do useful things. And on a gigabit connection, you can actually get some stuff done. So we might get it to the point where it's doing like offshore data processing, where if we need to crunch through a lot of capacity, one of the nice things about having this offshore lab is that rather than using all the compute of PHI, which is quite vast but is not unlimited, we can offload like less time critical processing tasks to the Wings lab at PCHQ and crunch through it on what will soon be, what is that, 32 times 3 and 64 times 4. So 256 processors plus like another 96 or so. Yeah, there's going to be like 350 or so processors in there, or CPU cores rather. And so with all that RAM and all that CPU, you can actually do useful workloads where you just kind of reduce the CPU load on the main cluster by doing that. So the other things that I want to do with the lab is there's Bakuya project, which is compute over data. If you're not into it yet, you should be. It's really cool. The idea is that you store your files, your source data on IPFS and on Filecoin, and it even has an S3 integration, which is cool with us. And what Bakuya does is it runs distributed Docker containers on the internet, which sounds like a really bad idea and actually is less bad than it sounds. And the idea is you submit your job, it takes in the input from IPFS, and then it runs a verifiable compute job against it, where the input is hashed, the Docker container that was run is hashed and you know exactly what state it was in when it was run, and then the output is deterministic. And so you can run the same thing on a couple of different machines and get the same result and verify that your computation was done accurately. And what you can do with this is like video transcoding or something like that, where you take a particular video that like might be you're a YouTuber or something like that, and you want to crunch it into a bunch of different formats, but you don't want to have to like deal with all the hardware of having it yourself. You can offload it onto Bakuyow project, and it'll durably store both the result and the source foot data on Filecoin and on IPFS in a way that's really, really, really hard to lose. And so I'm going to be running a couple of Bakuyow project nodes. I've become an honorary Bakuyow project team member as well because they really, really like what I did. I wrote a tool called Backboot, or Bakuyow Bootstrap, which is an Ansible installer. Sorry, it's actually a bootstrapper that installs and uses Ansible to install Bakuyow and then uninstalls Ansible. It's kind of ridiculous, but it's probably going to be like the most official way to install Bakuyow soon, written in Python, and extremely flexible, and also capable of, at least on the playbook side of it right now, you can spin up an arbitrary number of DigitalOcean nodes, automatically set up Bakuyow, get them on the network, including port access, run your jobs against that cluster, and then tear it down when you're done. And you can do this all with like a couple of commands, or rather one command, and then like hitting enter, and then waiting until you need to tear all the nodes down, and then hitting enter again, which I know is really hard. So yeah, Bakuyow project is like one future for the lab, and then ultimately what I'm doing while I'm over there is I'll probably be buying like a couple of low power computers and getting like a couple of external hard drives and two MoosFS chunk servers in straight replication mode, and just keeping all my media collection that I want to keep cached on those two, and just having like 16 terabytes effective media storage. And then essentially anytime I want to like watch media or whatever, I'll have like a local cache of the most important stuff in the UK ready to go. And so that'll be like what I stream from. I might even do something stupid like have like a caching proxy or something like that that actually like dynamically does this. One of the like sillier things I did many years back was MoosFS. You can actually run over zero tier. So zero tier is like a thing that allows you to bridge networks together and make them look like one layer 2 network. Like it goes even further than WireGuard or OpenVPN does. And you can run MoosFS over zero tier. And at one point, part of my storage cluster was just randomly on DigitalOcean in Singapore. And just certain files, you just would only be able to download at 100 megabit per second for some reason, almost like that was the speed of my internet connection. And yeah, so these tools are cool. They're very flexible. You can do amazing things with them. Thank you all very much once again for listening. And unless anyone had any last questions, we'll for coming. Cheers.